1-0 real numbers. Essential question. How do you classify numbers? Before I get started, I'm going to move this up a little bit because it looks like some of my vocab words got cut off on the bottom. So these are all the different types of numbers that we are going to classify. There really isn't a lot to the notes today. It's mainly one slide after we classify all these different types of numbers. So natural numbers are your counting numbers. So if you were just about to start counting, most people would start with 1. 1, 2, 3, 4, and so on. Whole numbers, I always like to circle or underline the O in whole to remind you that whole adds in the 1. So the 0, and then 1, 2, 3, and so on. So the only difference between natural numbers and whole numbers is whole numbers include 0. Integers are numbers you generally would find on a number line. So positives and their opposites. So -3, -2, -1, 0, 1, 2, and 3. Rational numbers. Rational numbers include natural numbers, whole numbers, integers, and then you can also have fractions and decimals. Irrational numbers are non-perfect square roots, so for example the square root of 11, and numbers that continue forever, or decimals that continue forever and never repeat. So for example, 2.12345 keeps going forever, never repeats. Real numbers are all of these groups. So real numbers are all of those groups. All right. Okay, what is a subset? Which types of numbers are subsets of rational numbers? So a subset is a group within another group. So our real number system has two subsets, rational numbers and irrational numbers. So it's kind of like real numbers break off into rational and irrational. The groups that are rational are the natural, whole, and integers. There aren't any subgroups in irrational. So no subgroups in irrational. Which types of numbers are subsets of the irrational numbers? So there aren't any subsets, but like I said, you can have non-perfect square roots and non-repeating decimals, but no subsets. Irrational does not have any subsets. All right, so now we're going to do a click and drag with numbers into each of these groups. Now the important thing to remember, if a number is natural, it is also whole and integer and rational. If a number is whole, it is also an integer and rational. And if a number is an integer, it's also rational. So you kind of work your way out. If you're the innermost ring, your number is also part of whole, integer, and rational. So really, there are multiple spots that all of these numbers can go. Okay, so let's start easy here. 0. Natural numbers are counting numbers. 0 is not a part of counting numbers. So I'm going to put it in the whole ring. Remember whole, the O in whole, that's where the 0 starts. I also could have put the 0 in integer or rational, because really it belongs in all three. Square root of 36. Well, the square root of 36 is 6. That's a counting number, so that's a natural number. It could also go in whole, integer, and rational. Pi. That is a very common irrational number, and actually one I forgot on the slide earlier, so I should add that right now. A very common irrational is pi. All right, if I have 0.35, that's a terminating decimal. It means it's a decimal that stops. Decimals that stop are rational. So if that is true for 0.35, that's also true for 5.7. 13 again is natural, whole, an integer, and rational. So I'm just going to pick one ring to put it in, integer. Remember, this 36 could also go in any of these three spots. Did that come ungrouped? Yes, it did. That's okay. All right, let's keep going. 0.3 repeating. Decimals that repeat are rational. Fractions, if you look on that first slide, we said are rational. Negative numbers. Now that one's a little trickier. If I count, my counting numbers 1, 2, 3, 4, 5, no negatives there. Whole numbers are 0, 1, 2, 3, 4, 5, no negatives there. Integers is where the first negatives come into play. 5 could go in multiple spots. We'll throw it in integer because we've got some space, but it could also go in natural, whole, and integer. You know what, maybe I will bring it to the most inner spot just to keep things making sense. So if it's in the innermost one, it's also in the outer ones. Square root of 71 is not a perfect square root. Non-perfect square roots, meaning a number times itself, you can't get 71, they go under irrational. Square root of 15 is not a perfect square root, so that goes there too. Now square root of 25 is 5, but we have that negative sign in front, so that's negative 5. Negatives don't come into play until we get to integers. Negative 4/5 is a fraction, so rational. Negative 17 is a negative, but an integer. Negative 15.725, that's a decimal, but it's a decimal that stops. So that means that is okay, it is rational. Square root of 16 over the square root of 49, well, the square root of 16 is 4. Square root of 49 is 7. So 4/7 is a fraction and is rational. Now 3.2146, since it has a dot, 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 that means the decimal keeps going forever and never repeats. The line above it means repeating. So if there's no line and there's the dot, 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 that means it keeps going forever and never stops. So that is irrational. So again, irrational is pi, non-perfect square roots, and decimals that continue forever and never repeat. Natural numbers are my counting numbers, 1, 2, 3, 4, 5, 6. Whole numbers, you add in the 0, so 0, 1, 2, 3, 4, 5, 6. Integers are numbers you find on a number line, so negatives and their 0 and their opposites. And rational, you add in decimals, repeating decimals, and fractions. And don't forget, if a number is natural, it's a whole, an integer, and rational. If a number is a whole, it's an integer and a rational. If it's an integer, it's also a rational. And remember that irrational and rational, all numbers are part of our real number system. So both rational and irrational numbers are all part of the real number system. Summary. Your homework for this lesson is a worksheet.